Hey guys, before you watch this video, make sure you went on the website and looked under today's date um, and checked your homework answers against the first two pages of the PDF. Actually, I think it's the first three pages of the PDF have answers for the even homework questions with the work, so make sure you check that first. I'm going to post two videos for you guys. This first video is going to be for the first question on the worksheet that you grabbed today. So the worksheet starts out with O'Brien's Ferry Company. It can accommodate cars and buses. So you have the toll for a car is $3 and the toll for a bus is $10. Cars and buses will be accommodated on different levels of the ferry. Given that the expected number of cars is 45 and the standard deviation is 2.2, we also know the expected number of buses is 15 with a standard deviation of 1.3. So up here, I just wrote some notes for myself. The expected value of cars is 45. The expected value of buses is 15. And then my standard deviations here for cars and buses. Okay, now the first part wants us to define random variables and use them to express the total amount collected by the ferry company. So this problem is going to kind of combine the ideas that we've been looking at so far. So what I'm going to do is, and you need to make sure you do this every time. Remember, we need to explain this like we're talking to a Bobo Dum Dum. So we're going to say let C equal the number of cars and let B equal the number of buses. So here I have T as my total for the total amount collected. Really, I should have that written down too. So T is equal to 3C plus 10B. The 3 comes from the $3 toll for each car, and the 10 comes from the $10 toll from each bus. So this should kind of remind you of like a let statement like you used to do back in Algebra 1. Okay, so that's our first part here. We defined our random variables. Now our next part, they want us to find the expected value of the total amount collected by the ferry company. Well, if you think about this, that means we're trying to find the expected value of T. So here I'm doing the expected value of 3C plus 10B. Well, we know, we talked about this yesterday, that if we have 45 as our expected value for our cars, just like when we talked about what happens when you multiply an average by a constant, right? If we multiplied all of our test scores by 10, our average is going to get multiplied by 10. Okay, same idea for the buses. So here we're going to multiply that by 10. So I do 3 times 45 plus 10 times 15. Now here I put my dollar sign back in to make sure, remember they're asking us about like the total amount of money, so make sure your units are there. Okay, and then for my last part here, they're asking us to find the standard deviation of the total amount collected by the ferry. They want to know what condition needs to be satisfied to be able to calculate the standard deviation. So I would like you to pause the video and think about what's happening here. Think about the situation with the ferry. Do the cars affect the buses? Okay, and talk about it with your square. Okay, at this point you should have decided with your square that this is an independent situation. Think about what they're saying here. The buses and the cars are on different levels of the ferry. So the car can't take a spot of a bus. So if they're independent, we're going to go and use that formula for standard deviation where we're doing the square root of the variances, okay? And the other thing you want to keep in mind here is it kind of combines our ideas. So I have 3 of these cars, right? So I'm going to do, or not 3 of these cars, it's $3 per car. So I'm going to do 3 squared times the variance squared, standard deviation squared, plus 10 squared times the standard deviation squared. And then square root this so we can get this as standard deviation. And that's going to give us $14.58. Okay? Now, this next part is so nifty because we're going to make a connection between what we knew about the normal distribution and what we're doing now. So for part D, I'm telling you that given that both the distribution of cars and buses can be modeled by the normal model, I want you to find the probability that the total amount collected will be greater than $310. So at this point, again, I'm going to ask you to pause the video, and I want you to work with your square and think about what we calculated in part B and part C and how that could connect to what we used to do with the normal distribution. Okay, so at this point, you've had a discussion with your square, and hopefully you've thought about the fact that, oh my gosh, holy skunk muffin, expected value, that's a mean. And then here I have a standard deviation, and they told me it follows a normal probability. So here I have my picture worked out for me. Okay, this is centered at a mean of 285. My standard deviation is $14.58. And I'm looking for things that are greater than $310, so I'm shading to the right. Now I want to calculate what that z-score actually would be. So remember, calculating a z-score is your value minus the mean over the standard deviation. So I have 310 minus 285 over 1456. And that's going to give me 1.71. Now before you start putting anything in your calculator, I want you to think about that value. Is it going to be something that's really unusual or not? Okay? Now, you should be saying to yourself that's getting kind of close to 2 standard deviations, a little bit unusual. Okay? Remember, we would write our probability statement. What's the probability that z is greater than this? Okay? Now, I'm not sure if we remember how to get this out of our calculator. So at this point, I'm going to have you pause the video and I'm going to have you pull out your Inspire. Okay, so let's see if my calculator wants to cooperate. I'm going to pull up a calculator page. Okay, so remember we can go to menu. Let me move this so you guys can see the whole picture here. So we're going to click menu, probability, distributions, and then we want to do normal CDF. So if we go back to this here, remember our picture, we're going from a z-score of 1.71 to really like positive infinity. So I'm going to do 1.71, and I'm just going to write 999 because that's really, really far away. Okay, and I get a value of 0.0436. Okay, so now let's go back and let's think about what they were actually asking us. That was the, let's see, so according to the normal model, the probability that the total amount collected will be greater than $310 is approximately 4%. So not great. Okay? At this point, I want you to take a look at the next question.